if you're able to achieve all of that, hopefully you'll have successful data. So thinking about the life cycle of research data, and I think that's one of the things that has historically made it much more of a challenge to interact with as a research output than, say, published articles or books, which will have a finished endpoint. I mean, you finish, you know, as you reach the end of your research, or in fact have already completed it, you publish an article and then you move on to the next thing. Whereas research data is a much more you know, cyclical process and much more long-term, ongoing. Thinking about this life cycle, you generally would start with something like a plan, which can include reviewing existing data sources, addressing informed consent, and thinking about costs, and in fact producing a data management plan. You've got the creating phase, where you're actually designing the research, filling the details of a data management plan. You're getting your consent, and you're doing your data collection and management. You're capturing and creating metadata. With the processing, you could be entering the data, transcribing, checking, validating it, perhaps cleaning it, and where necessary, anonymizing it as well, and describing it, and starting to think about its storage. The analytical phase, analyzing phase, is about interpreting the data, perhaps deriving the data, running it through the models, producing outputs, and authoring publications, and basically preparing for the sharing phase. Preserving data, that's about the storage, it's the backup, it's finding the persistent identifiers, it's creating robust metadata and documentation, which as you prepare, if you like to at least put your relationship with this particular data on hold or into status, it would enable you or somebody else in the future to be able to re-access it. And then you've got the sharing, so you've got documentation, you've got to think about where, what sort of repository you're going to use, if it's going to be a public one or if it's going to be one of the controlled access. And then finally, you've got the reuse, potentially either you or somebody else doing follow-up or new research. And again, new reviews, scrutinizing findings, and perhaps contacting the original data instigators, data collectors, with any questions or comments or requests for updates as well. So thinking about how to improve research data quality, I think we can all agree that collecting research data is in and of itself one of the challenges of conducting research, and there are generally going to be opportunities to improve what data are collected and how they're kept and otherwise processed. So and at a high level, high quality data needs to be demonstrably fit for its intended purpose. It should correctly describe the real-world construct for which it's described, and it should meet these criteria. It should be accurate, accessible, complete, and reliable. And those are, again, they are pretty, they're high level, they're quite generalized terms, and I think often they're going to be ideal rather than what can realistically be achieved. I think they're the objectives for which we should be aiming when we're conducting research. So some of the quality issues that, or the challenges that actually people come up against are things like missing values or incomplete data, which obviously is going to be a problem of any sort of processing, and might happen for a variety of reasons: machine malfunction, human error, for instance. There could be incorrect information due to input or processing errors. So again, that could be either a human or a machine issue in a variety of cases. Duplicates of information. Sometimes this isn't much of a problem, and deduping can happen at fairly sort of standard ways. But for something like a meta research project, duplication of information could cause some real severe issues around erroneous conclusions. So that can be a really big problem. Uneven representation of data. again, if some data are more fully described than others, or if you've got years, for instance, financial years in some data sets versus calendar years in others, a lot of these things can end up aggregating to big logistical and accuracy problems. And then again, it's surprising how often logically contradictory values will come up, and sometimes that might be just to do with formatting, or people using different systems for recording. But again, it can end up with be quite difficult to find why the outputs are not looking right. It could be because of something like that. So some key questions to ask yourself when assessing research data quality. If the data or the research information has been peer reviewed, can be really helpful with instigating trust and being able to rely on some of these challenges we just talked about having been already sorted out. So can the data quality then be evaluated with the information details provided? So that's around, as we were just saying, things like documentation and metadata. Are they sufficient to enable proper data evaluation? And are there any potential threats to the validity of the study or the information? Are there important things missing? Have there been any questions raised or concerns about perhaps published work that's been based on these data sets? So again, there are questions that can be asked and additional research that can be done to check around data quality. And again, those are useful questions for the people collecting the data, conducting the research, to ask themselves for their own, for making sure that the research data they're producing is robust. So thinking about some challenges with associated with maintaining data quality. So if you've got very varied data sets, if it's lots of different types of data, perhaps with a lot of different characteristics, there's just very, very complicated data, if you like. It can then basically make errors or other issues interpreting challenges just that much more difficult. And of course, enormous volumes of data, particularly if it's an ongoing process, which is just becoming just greater and greater. It can be really difficult to keep track of it and to make sure that all the incoming data, if you like, is treated uniformly and cleaned and integrated effectively with what you've already got. And also, I think what a very wide-ranging problem, even in a range of smaller data fields, is the issue of there being often not very well understood or very well used standards around how to collect data, how to sort of label the data, what your parameters are, sort of standard terms, that kind of thing. And again, if you're trying to conduct your research in an environment without that framework, again, it makes it much more difficult for you to produce, as we like, data that are of high quality, but also data that are demonstrably of high quality as well, because other people then don't have those signposts to be able to check against. So some ways that you can in fact, increase or maximise the quality of the research data that you work with are to think about some of these particular characteristics and criteria. So start off with availability. Making your data available is also about making it accessible. So reducing, where possible, the level of difficulty for users to obtain the data. And that's not just about making it, if you like, free to use or just a couple of click-throughs, but also think about what the interface itself looks like, so that people are actually able to find what they're looking for. And then if there is a process for registration or for purchase, again, making that easy to understand and ideally, I suppose, manageable, monetarily speaking. So timeliness around availability. You basically want, ideally, if you're wanting to make it open ultimately, is to think about how much you can reduce the time delay from data generation to acquisition to utilization. That can be an issue if you've got, again, multiple partners, if there are publications or patents involved. But again, if you're thinking about things being sort of timely as a default, as a starting point, it is a way of ensuring that your behaviour is going to do you the most good, because you'll be updating the data regularly. You'll be thinking about how to meet the needs of your ultimate end users, and that should then again improve your quality. And then thinking about authorization. How do potential users achieve authorization? Again, is it something which data anybody can use? Do you have to get some kind of reference or be a member of an organization, or some other kinds of authentication, or not? But in any case, try and make it as clear as possible what is required. And then thinking about usability. Definitions and documentation. So that's around the names, the definitions, the glossary of terms, standard formats, anything that you can do to make it so that people will recognize what it is that they're looking at. Metadata, if you like, is a specific type of documentation, which is often used in cataloging or as keywords, or other ways of giving the signposts of what the data actually are. So again, it can mean that people are able to sort of filter through and find what it is they're looking for, particularly in in large scale data searches, and it can also sometimes, I think, mean that you get new users or people who would not otherwise have realised that your data set was relevant to them, because you've got a good comprehensive metadata schema, and it does speak to them. They do recognise what it is they're looking at. And credibility, ensuring your data are credible. You can use basically reliability of the data sources, data normalization, and provide really clear information about sort of data stamping, data time stamping. And again, it's sometimes impossible to entirely clean up your data as you go along. But if you're able to do routine audits to try and normalize your standards and just other parameters which you're treating the data, again, that's going to help with its credibility and reusability. So reliability, accuracy. So again, it's around being unambiguous. It's about wherever there are well-known, understood, or practiced sort of standards or way of doing things, that you're incorporating those. And again, consistency is also part of this. So as you can see as well, a lot of these characteristics are part of each other, or they relate to each other. So you want logical relationships to be really clear and again consistent from column to column, or facet to facet, and or from data instance to data instance. You want to be able to show completeness, and to make sure that everything that all the values of particular data sets or data points are valid. And if there is for some reason, if there is something blank, if something isn't complete, to not just ignore it, but to acknowledge it, and to either put in a note about it, or to put in an estimated value with a note as to why that's the estimated value. So again, just thinking about how to show that it's been really well thought through, what it is that how you treat the data. And then with the integrity, making sure the data values are standardized, and that the data model and data type are appropriate or applicable to what it is that you're trying to investigate. So data relevance and fitness refers to the amount of access data sort of used by the users, the relevance of the data, the degree to which the data creates matches the user's needs. So again, thinking about where you're pushing the data, how you're describing the data, and making sure that that's really accurate to what the data are going to be showing, or the data uses are that could potentially be provided. So again, the data description, classification, and coding content should all be relevant, and they should be for the person of appropriate expertise, easy to understand. So I think it's important to state it doesn't need to be understandable by anybody in the world, but it should be understood by the people, your peers, if you like, the people that you're trying to reach, perhaps people from adjacent subject domains or people with relevant training. And then finally, thinking about the presentation quality, readability. So again, that's around making it just so that people, it's properly, what's the word I'm looking for? It's just displayed in a way that people are going to be able to easily soak up the information and what it means. That people's that numbers aren't just given no context at all, that there's appropriate connections made between things as well, so that again, people and machines can find what it is they're looking for and understand and move through the information flow appropriately. And again, the more structured, the better for the search engine optimizers as well. So again, you have more hits in something like a data mining exercise, or somebody doing an internet search, or someone, and also then future AI or other initiatives that are seeking information or data that you actually already possess. So basically, make it easy for people to find it and understand it when they do. So thinking about the research data management, there's quite a good definition here for what research data management is. Got the effective handling and appraisal of information from the point of creation through dissemination, publication, and to archiving. So it's really at the end-to-end process of the data. And why is it essential? Well, I think as we already know and have touched on, research data and its management is absolutely pivotal to the scientific and scholarly process, and you need it in order to be able to show compliance with policies. So basically, institutions or funders will likely have research data expectations and policies that you'll need to abide by. You need to be able to show that you're doing that. You'd also, as a researcher, be able to demonstrate responsible practice. So if you manage your research data well and make it publicly available where appropriate, that's going to help in being able to demonstrate the responsible use of public resources for, say, publicly funded research. It also improves the validation of the research results themselves, and it enhances the research integrity by showing transparency. And it also provides opportunities for the data to be made more accessible. So again, good research data management is not just about the publishing or pushing the data into a repository. It's also about providing the documentation and the metadata, and also ensuring that it's longer term availability. It's not just in somebody's desktop, it's actually in a proper repository. So if you like, that was a bit about why institutions and funders and the general public may want good research data management practice, but more specifically or more pertinently or immediately to researchers, data are scholarly outputs, and and researchers, I think it's incumbent upon us to treat data appropriately as a scholarly output and with respect, and to see it as being part of our research practice. So well-structured, accessible data will allow easy replication and validation. So it builds that opportunity to show the that it's good quality research that you've been doing, and to build that trust in the knowledge overall. Research data management, as we've touched on, can also support longevity for data, where if you just have a project website or as I say, a laptop, data do become lost. They become disconnected from research canon. So good research data management should support that not happening. You should also support, hopefully, an increased collaboration opportunities and an ability for people to be able to find connections between things. So again, the sharing, the rediscovery, and the connections will all be supported by good research data management. And hopefully as well, in the long term, that it should save time and resources. If we better know what it is we know, then we don't keep having to do the same experiments in slightly different ways over and over. We actually can make these connections, and we can then start building on them and become more ambitious in what it is we research. So just looking at it in a slightly different paradigm, if you like, and because it's so important. Robust, appropriate storage facilities will help keep research data safe and secure. The research data management itself will enable organisation of the data for the easy access. So accurate and complete data helps in validating the research results and increases research integrity. So that's the trust and transparency and so forth. And then if the data are precisely described and formatted and attributed, that improves the visibility of the data as a research output, and it should, through increased impact, actually increase things like citation counts and other accreditation opportunities for the researchers that contributed. And then the sharing and reuse of research data will ultimately increase the collaboration opportunities within the research community, again, partly by increased profiles of the researchers, partly through these opportunities for this sharing and reuse, and then building the trust in the canon, in the research, in the knowledge that's being generated, and also partly because as the knowledge itself grows, new questions are going to be possible to be asked, and so new collaborators and domains and so forth could become relevant to your field of inquiry. So thinking about some of the things that you would use to improve your data management, a really key output and structure is the data management plan. So I want to mention, we're actually going to talk about a little bit about a couple of the data management plan tools which are available. But I think it's really important as well just to go through what it's for, what it contains, and for you to have a think about what that looks like for you and in your research. So a data management plan is a structured document that describes basically the data that you expect to acquire or generate during the course of a research project. It could well be being generated at the beginning of a concept discussion, or as part of your submission for a particular grant to a funder. The data management plan will also describe the means by which the data will be managed and described, analysed and stored. And it will give it details of the mechanisms that will be used to share and preserve the data. So thinking about the key stakeholders, there's quite a lot going on in this slide as well. I think the concern, the responsibility always starts with the researchers themselves and with their institution. They've got the closest involvement with the research data and therefore the data management plan. And they've also got the greatest responsibility. I mean, it's the entity that's being funded, charged with the task and the reward for producing the data. The funder, who's providing the money, is going to want to know details about what it is they're funding. What do the researchers and the institution know about this topic and about how to treat the data that's going to be arising? What's it going to cost? And how they're proposing to manage all of these questions. Commercial partners, as part of research projects, are also key players at this point, because it's often really important to get expectations understood and set very clearly at the beginning of a project, so that if data, for instance, are going to be embargoed as being commercially sensitive, that's something that the funder should be told at the very beginning of the project, so that you don't get to the end of the project and then the funder thinks that it's going to be open data, the commercial partner thinks it's going to be closed. So again, a data management plan is a really useful way to work through all of these things early on. And then there are publishers, for instance, who don't have a direct link with the data or data management plan, but they may wish to cite it or to link to it. It may be that the data management plan's got some standard metadata included that the publisher would publish, and increasingly as well, many journal publishers are looking for data availability statements, which again could be something that's generated from the data management plan. So, got some key considerations for when you're developing your data management plan. So we start off with how will the data be created, through what processes, again, what instruments, how will it be documented, and that could be the range of electronic lab books, there could be videos or other instruments again. Who will be able to access it, and that's something that's going to perhaps change according to whereabouts in the project, the data or the research, overall research project are actually situated. Where will it be stored? And from many countries, for instance, it's really critical to know which whereabouts the servers for the data will be located. Who will create a backup? That could also be if there's a multi-country project. Will there be backup copies in a range of institutions or countries? And then whether and how will the data be shared and preserved? So if you like, again, whereas published articles as an output to something that once published, researchers don't have much responsibility over, apart from perhaps to report to their institution that they have completed a publication. Research data can have a much longer term relationship with the researchers and with their institution. So remember, as I said, that there are a lot of template tools which will take you through a lot of these fields. But again, I think it's really important to have an awareness of what researchers should include in a data management plan. So you've got the plan essentials. So you need the basic identification information for your project. So it's the title, author information, point of contact. You need the estimated time frame for the project, so that starts and end dates and data collection periods. So it's often that'll be subdivided into particular work packages or for particular working groups doing things, and they could also have some contingencies or dependencies on each other. We need contact information. That's for authors, collaborators, and other stakeholders. So again, that could be instrument providers, or could be even data center managers as data actually start being relayed towards the data, the endpoint. You should provide information on who has the overall data management responsibility for things like the acquisition, processing, quality control, documentation, preservation. And again, that's to make it easier for again, if there are any problems or any issues that start arising, they can be dealt with as soon as possible. You need the estimated budget, and often that will include things like in-kind commitments as well. And then data sharing agreements, memorandum of understanding. So that gives the roles and responsibilities, and that would include as we saw in the previous slide, any expectations, embargoes around commercial uses. It could be around international agreements, or it could, or it could be that that a particular project's got several funders contributing, and they each need to be acknowledged, and these things need to be worked out at the beginning rather than at the end of the project. So second slide on this, data acquisition, processing and storing. You need the basic identification information for each data set. So again, there's a set of fields which you want to be consistently recording for each data set, and keeping a record of all the data transformations that conducted to produce the data sets. And if you think about this as well, this sort of record keeping is going to make producing journal articles or other outputs or reports around your project much easier if you're doing this as you go along. So you list data inputs and calibration details for models and softwares and codes, and identify and document who shares the responsibility for the data preservation. So again, just thinking about, if you like it, providing information about PIs and collaborators and authors and things is not just about credit, it is also about responsibility, and about potentially trying to understand or ameliorate any problems that might come up. And again, state which trusted digital repository you plan to use. That's often going to be really important for particular, say, funders or institutions, because they may well have relationships with or trusted repository lists, which they are going to want to see used to be able to fulfill their own mandates and their own requirements for security or cost. So then, and you also want to think about the data publishing, sharing and managing as well. And how do you propose to retain and update the detailed metadata records? What persistent identifiers are you going to be using, and how are you going to be using them? How are you going to be creating the metadata? Is there a standard way that's going to be happening, and who will be doing it? And again, the location of the internal storage resources that will provide the replication and backup capability. So it's just where everything is, who's going to be in charge of it, and instilling as much sort of trust in the overall pipeline of the project as well. I was thinking about the research data as being this resource that you don't want to lose information about, because anything that you lose is going to detract from its ultimate usefulness. And here we have some of the funders that are already requiring data management plans. Some others are just, if you like, inviting them or encouraging them. But I think it's something that's increasingly becoming, certainly in the sciences, a standard. And I think that will increase rather than decrease. But hopefully, as it becomes more common, it will also be something that becomes more automated, and becomes basically easier to do. And as I mentioned, there are a couple of the tools that people, institutions, so forth, are using to create data management plans. And sometimes, I think, for instance, like NIH in the US, they will actually be linking you to the particular version or format that they want you to use. I think Welcome in the UK also does that. So again, where I think it's particularly helpful when funders actually do provide those signposts to their potential grantees as well about what's going to be required. So we should go on to data repositories and their role in data management. What is a data repository? There's a series of kind of interlocking definitions here about the functions and, if you like, faces of a data repository. It is an archive that curates the different data sets for analysis, distribution, reporting. It can also be seen as a scientific vault that fosters preservation, long-term availability, or a platform, almost like a publisher, if you like, that enables multiple stakeholders to share data. It could be seen as an archive that houses the data and its associated metadata, or as a library that enables the researchers to access and cite and share. So again, it's probably a lot of different things to different people, and perhaps even different things to the same people, depending upon the function or the interest they have at that time. So thinking about the data repository lifecycle, it begins with, say, capture, which is where the experiment or the research project and the initial data are captured and progress towards uploading. You've got the catalogue, where you're adding things like disciplinary metadata, assigning perhaps a digital object identifier or other identifiers. Then repositories will typically allow instant searching and viewing and retrievability and downloading of data. And as they progress, repositories are increasingly allowing synthesis of data sets and data fields to facilitate insight, discovery, and verification of the data. And then looking a bit further out, an online global network environment, this is going to be increasingly accomplished through data harvesting and the possibilities of linked data and data visualization. Again, it's starting off, I think, looking quite like a comparatively sort of human process, human to human. It's becoming more kind of automated and driven by the systems and the data itself as you go through that cycle. So not all repositories will do all of these things. Many either specialize in particular services or domains, and some of them will also serve different sorts of communities as well. So again, there are variations among data repositories, but again, most of them will facilitate data discovery. They'll allow research dissemination and synthesis on a global platform. You'll allow the interested potential users to have a look at and index what they're seeing. They should hopefully provide opportunities for curation to increase usability and interoperability. I think where journal publishing in the past has sometimes fallen down is it's given far more emphasis to extreme or unusual results than it has to boring or negative or null results, which conversely actually were more important, because that's really the situation, if you like. And I think that data repositories are a really useful way of counteracting that drive towards the extreme or the unusual by providing real evidence of the sort of the standard state of a body of knowledge. So again, I think that's a really important thing. Repositories also provide, as I say, these persistent identifiers. They're really important for the preservation and long-term retrievability of data, and they're also a way of signalling compliance for mandates. Again, if you've lodged your data in a trusted repository, that will often act as a shorthand for a number of processes and hurdles that you have gone through successfully. So again, that can be just a really useful way of being able to report back to your funder. So you've got various types of repositories, we say. You've got self-service ones, which are free, easy to upload, very non-standardized, if you like. So they can be a bit of a dumping ground, but I think they are also very, very useful. And then things like Figshare and Zenodo and Dataverse. You've got institutional repositories, usually run by institutions. And again, I've got a few examples there of specific ones, and they're usually used by the researchers from that institution. Domain repositories specialize in particular subject areas or file types, and they can often be much more closely associated with specific funders, and also they can cost, they can charge often for ingesting particular data. And then you've got these hybrid ones, which are a combination, so Dryad, which is generalist in some ways, but also provides some peer review facilities. And also sometimes people will be able to interact with it free, sometimes it will cost. So so again, there are a range of these different sorts of options for people, which hopefully will mean that whatever your situation, there will be a group of repositories that are suitable for you, but then can also mean it becomes complicated as a decision in itself. In which case, here are some of the criteria to think about. If you are thinking about what your particular research is going to consist of, the research domain of the repository, it becomes very important. You've got the sensitivity of the data, so that might mean if there's like medical or other sensitivities, you might need a repository that's HIPAA compliant, for instance. Repositories will operate according to different licenses for the data sets. Some will just operate on, basically accept whatever license you wish to impose as you send it through. Others will actually have their own set of standard licenses, and they won't deviate from that. So again, you need to be checking these things. Again, and also depending on the project and the data set, you may need quite a lot of quality control. You may need support on the actual submission and access to the data. You might need for a very large data set, specific tools. You might need standard metadata fields and vocabularies. There could be a particular audience or community that coalesces around this particular repository that you wish to reach. And it could be that there's a cost to working with specific repositories. Again, that could be something which is important, or it could be something which is already dealt with in an award. And also then there's the more, again, social situation, the reputation of the repository, which might be nothing to do with the quality of the tech or its ability to ingest. It might be that they're very difficult to deal with, or that it could be that there's been some blackouts recently, or that they're not transparent about their governance. So again, these things may or may not be important to you, but you should investigate. You should work out what it is that your attitude is towards these things. And further criteria include what guidance you're getting from your funder or your institution, and sometimes journals can also be helpful, particularly if it's if your project and your say published article is perhaps from a smaller project which didn't have a huge budget or instructions around what to do with your data set. Fair data, which we'll go on to in a moment, is also increasingly important. So do you have opportunities for embargoes, to keep something back until something else has been published, or a certain amount of time? What kind of formats and file types are looked after? Do you have any other requirements around sort of access, or even something like is there a help desk that's available at the same time that you're awake? If it's something that, if it's a data repository that perhaps is in a different part of the world from you, does it provide you with, if you like, the things that are going to support your own quest for kind of credit and credibility and scholarly accreditation as well? So that's things like, is there evidence of good usage? Can you see downloads? Can you see who's using or reusing your data? Are you provided with digital object identifiers? Is it connected with any scholarly communication networks or other organisations that are going to help you, build your own researcher story as well? So just thinking about some of the data sharing and reuse principles. Why would you want to share research data? Ultimately, it's to advance research innovation, basically, and to build its Validity and reputation. It's to basically maximise the research, the worth of the research as well. The more it's seen, the more it's reused, the more valuable it becomes. So that impact works as an equation, if you like, both for funders in terms of how useful, how well they have chosen, and how they're banged for their buck in terms of research outputs. And it's also really important for the researchers as well. It provides sort of evidence of it's part of your scholarly library that you can sort of share and use to bolster future collaboration opportunities, and increasingly as well, really valuable data sets are starting to make a real difference to people standing in their scientific communities. Again, gold standard, multiply cited research data sets. Encourage other people to come and think, ask questions, and reuse and credit. However, there are quite a lot of instances where people might not share their data. This is part of a PLOS study that was published in 2020 from a survey conducted in 2017 and 2018. So researchers may or may not make part of their data available, at least for reasons like they need to publish first, they could have insufficient time to make it available, by which I think they want to make sure they want to do those checks that we were sort of talking about, to make sure that the data are kind of full and complete and rigorous. They may not have the right to do so, and they may not have the funding to do so, and that might be around the time to the resources to get somebody in who's an expert. It might be that they don't have the funding to put the data into a sufficiently reputable repository. I think a lot of these look like excuses to me, but I think if you like, at the moment there are real reasons that people have given, and I think that's something that's important to remember and think about how to counterbalance those and strengthen reasons to share. So who will have access to the data and at what level of access they're entitled is also an important consideration, because providing open access to confidential data, providing access to unauthorized people could be, not only dangerous but also unlawful. Again, thinking about some of the medical examples, if people can be identified personally from medical data, that's very, very dangerous. But for basically, generally though, data should be acknowledged when it's reused or accessed by the people that reuse it. And they should also, I think that again, the earlier that the people creating the data can think about what the accessibility issues are and what licenses and other potential restrictions could be required, the better. So that to think about these things as soon as you can. To say we would touch on FAIR as well. This has been around for about 6 years now, and it's basically an acronym to try and help support, again, data quality and also the way that data is reused and interacted with. So you've got the findable, how discoverable is data, and how basically how easy to basically connect with, how accessible, so it's not necessarily open, but how minimal are the restrictions that can be put on it, and are the software or other interfaces required are available as well to be able to access. You've got the interoperability. Can the data exchange be conducted between subjects, between countries, other organisations? Are there standard vocabularies, for instance, as well? Are the metadata in good form, in good shape? And then the reusability. Again, the licenses. What reuses are there any? Is there an end date for reuse as well? What are the permissions around all of that? So we've got a sense of what there are some good, mediocre and bad data practices. The good practices support fair data principles and hopefully will guard against data loss, help facilitate sharing with other researchers, and also provide opportunities for the long-term curation and preservation. Mediocre data practices have some potential to make the data findable with additional effort, but aren't obviously connected with being able to making things more fair. And then you've got the bad data practices, put the data at risk and make it difficult for people to find it or to preserve it. And it might be, for instance, by this data just being left on a personal computer or even on paper. Got a bit more information from that survey here. Just looking about how there's also changes. There are differentials across research subject areas. Some areas, looks like environmental sciences and earth sciences, are more interested or open to the idea of sharing than some others, say engineering and psychology. Well, I think that's probably a bit more granular than that, even still. I think there's probably geographical variations as well, and institutional, and probably personality and career stage differences. But again, there are differences, and I think it's useful to be aware of these, and to be aware as well that whatever my situation is, that other people are dealing with different situations, and there may well be opportunities to benefit from that and to learn. So just thinking a little bit about why it might be useful to reuse data as opposed to generate fresh data. So basically, I think the headline is it potentially saves time and accelerates the pace of scientific discovery. It's going to hopefully just validate and verify and increase our trust in the knowledge that we already have, and also as we become better at it, at reusing, we will be able to kind of grow our capabilities to actually do that as well. So again, that it's a worthwhile skill, and it's something again to be thinking about when you're crafting your research data. Is this going to be reusable? Having said that, there are concerns and challenges. I think basically trust, or establishing trust in data, is really important. You need, I suppose, there's data reuse. If you can reuse data, it can then start to become a benchmark in that particular field. And but you also do need sufficient expertise to understand the data that you're working with. And I think, again, that's something that is not necessarily well defined at the moment, but I think people are becoming better at understanding what expertise is required. I think with areas where there's very little data, the temptation or the challenge around reusing it could be that it's overemphasized, if you like. Small samples can be used to do too much work in making overarching hypotheses or conclusions. So you've got essential elements of a data reuse plan. Basically, what you need to describe it. What is the research project? What are your goals? And how does the data relate to it? You need the title. You need any other permanent identifier, but preferably a digital object identifier. The data source and sources. Again, do you have persistent identifiers to back those up? You need some standard subject descriptors to the disciplines, and also any related publications. Who's doing this? Who's the data collector? Who are the funders? Who are the collaborators? And most importantly, who is the contact person for all of this? And you've also got the location. Where the data collected, when the data collected, and again, everything being as specific as possible, and where possible, use persistent identifiers. Use research organisation registry identifiers, for instance, RAWs. Use grant IDs, and all and ORCIDs for the people as well. So where possible, make these things persistent. And how as well, what instruments are used, how is the data being processed, and then how is it being indexed, what are the formats, and what standard metadata are you going to be using. And again, as much as anything, being explicit about these things as early as possible gives people opportunities to consider things, to perhaps do a bit of research and improve and tighten, and just basically make the whole project that much stronger. So I was going to do a few slides on the role of artificial intelligence. So AI and machine learning can support data management by improving operational efficiency, improving data accuracy, accelerating therefore the productivity of the data scientists, who can then move up the chain, if you like, of tasks that they have to concentrate on. AI can effectively manage the data lifecycle, thinking about sort of dates and things being triggered, triggered things that might otherwise get forgotten. They can create and update data sets in a user-free manner, and also, as they support this proactive and reactive data maintenance. So they're going to be a real help in ensuring the ongoing longevity of the data quality. So they can also be applied in all phases of the data lifecycle. So you can have AI creating and enriching data assets in an efficient, user-friendly way by identifying patterns and autofilling. You can have it maintaining the high-quality data by supporting the proactive, as I say, data and reactive data maintenance and for data unification and deduping. You can help with the protection of the sensitive data and the retiring data, and then you can increase the use of the data by improving its discovery, specifically for data scientists as well, and providing things like recommending services and linkages. So the take-homes. Data management plans in a nutshell just clearly state the opportunities, requirements and challenges that could be encountered when managing research data. They define each aspect of the data creation, use, management prior to drafting your data management plan. And if you can create a data management plan at the outset of your research project and periodically review it, it's going to help keep you on track, and also help you notice when things do start changing, as invariably they do, but it will enable you to then take appropriate action to work out what you should do. They'll help you with ensuring your compliance with your institutional policies as well as funder policies. And they will also support you in in your long-term storage, in your outputs and publications, and that's what you do with them, and where they go, but also in things like writing them, and supplying things like documentation and other reports and outputs. So some smart tips for you. We've got, please, clearly define the means for storing your research data before you start. So what you're going to be using. Try and preserve the data in the most appropriate format independent manner. So it's where possible, rather than Excel, go CSV, that kind of thing. And also, as well as obsolescence, that also helps keep you out of being bound by licenses. Or by and therefore prevented from sharing in the future. Make your data accessible using a data sharing system if you can. Make it discoverable by linking it wherever you can with articles. And again, that connection builds it builds both ways. So data sets linked to articles can also improve citability of the articles themselves. So provide the best metadata you can for the greatest amount of comprehensibility. Ensure you don't have any missing elements if you can. If there are any missing elements, address that. Attach the user license to the data set at the time of the storage, and so that will show any user what they need to do, what they can and they can't do, and how to credit you. And also find effective means for sharing the data and methods. Basically, the greater transparency and the more ways of conducting smart scientific communication, you're going to find. Right. I think we might have overrun slightly. I will see if there are any questions. Okay. Oh, someone's asked if you can have access to the recording. So I'll leave that to my hosts to answer. Yeah, people want the slides. Basically, I think that's fair. Okay, so I think people I don't think have any specific questions, but they are interested in knowing about the slides and the recording. So I see that in the chat it does say that there will be a recording of the webinar shared with all the participants, I'm pleased to say. I think you should also have a look in the chat to see if there are any coupon codes or other discounts that you want to take advantage of. But other than that, I just wanted to say thank you very much, everybody, for attending. I hope it was useful, and I hope the rest of your day goes really well. Thank you.